Hello, I'm Malika, and for our assignment in machine learning module, we chose a supervised learning problem. For that, we have to implement four models. So I chose random forest classifier model to train. The dataset we chose was the UCI heart disease dataset, which has patient data of heart disease patients. And this is the overview of the dataset in Kaggle. So after getting the dataset, I started training the random classifier model. Here is the model, and first, I handled the missing columns, and then I moved on to uh, choosing. I converted the binary classification, converted some columns into binary classifications, and also I handled missing values. Um, and I started training the random classifier with 100 trees, and I got the top 10 features to train the model. First, I trained with five features, choosing five features from the dataset. It gave me 53% accuracy, which was very low. So I had to move on to choosing more and more features. And in the end, I stopped with 10 features, using 10 features, which were really important. So I had to choose the top 10 features first, and after that, train the model using those 10 features. And after that, in the end, I received 83% accuracy, and then I moved on to implementing the backend part for this for my part. So I basically uh, saved the PKL files from the train model, and saved them and downloaded them and saved them in the backend folder. And then I started implementing the backend and making an API call named predict. So I called that in the front end and give the output. So, so this is how my front end part looks like. So basically, it gets the inputs from the user and predicts if whether the patient has heart disease or is in risk for heart disease or not. So this is the data of an heart disease patient. So I entered them. He should be high risk according to the data. So let's predict, give a prediction. As you can see, the model is working fine. The model is outputting the risk of the patient as high risk, and the risk is detected. Then let's move on to a patient that is in low risk, and I enter the data, and let's see whether it gives the right output. As you can see, it gives the right output with 83% model accuracy. It gives good predictions. And that's it for my part. Thank you.
Hello everyone, I'm JC Vitanagamagi. Today I'll be demonstrating my contribution to a machine learning project which focuses on implementing the k-nearest neighbors algorithm for heart disease prediction. I've applied KN into the Cleveland heart disease dataset, and we'll walk through my implementation, pre-processing steps, and results. So uh, about our dataset overview, I'm working with the Cleveland heart disease dataset containing records from 920 patients with 14 attributes. They're including age, gender, chest pain type, blood pressure, and cholesterol levels. For this project, I've simplified the target variable to binary classification. There are 0 for no heart disease and 1 for presence of heart disease. The dataset is relatively balanced with 411 negative cases and 509 positive cases. About my data pre-processing part, my pre-processing workflow included several critical steps. First, I handled missing values, particularly in the CA and TEL attributes, and then encoded categorical variables like CP, REST, TCG, slope, and TAR using label encoder. That most importantly for KNN, I applied feature scaling using standard scaler to normalize all features, which is essential since KNN relies on distance calculations. And finally, I split my data into um, 80% for uh, training and 20% for testing. Here are what I said previously. So after that, exploratory analysis revealed that chest pain type, maximum heart rate, and number of major vessels had the strongest correlations with heart disease. Mm, I also found that patients with heart disease tended to be old around 56.5 years compared to 52.1 years for those without. For the initial model, I implemented KNN with K5 neighbors using skitlearn. The key part of my implementation was determining the optimal K value through cross-validation and iterative analysis. Then my final model achieved 85.5% accuracy on the test set. The confusion matrix shows 22 true positives, and 31 true negatives with only 3 false positives and but 6 false negatives. The ROC curve demonstrates excellence discriminative ability with AUC of 0.93, significantly better than random chance at 0.5. Despite good performance, I identified several limitations. Cannon's prediction time increases with dataset size and it's sensitive to the curve of dimensionality and noise data. It also provides limited interpretability compared to other algorithms. For future work, I recommend implementing feature selection techniques, exploring weighted KNN variants and possible combining KNN with other classifiers in an ensemble to further reduce false negatives, which are particularly critical in medical diagnosis. To conclude, KNN proves effective for heart disease prediction with its simplicity and flexibility. The implementation demonstrates how proper preprocessing, particularly feature scaling and hyperparameter tuning, mm, can maximize KNN effectiveness for medical diagnosis applications. Uh, Here are some hyperparameters tuning, finding optimal K, and this graph shows error rate versus K value, and then this graph shows cross validation accuracy versus K value. And here I am did some additional analysis for testing different distance matrices. So in this final chart, this is the KNN performance with different distance matrix. So that's all about my part. Thank you.
Hi, I'm Beam Surveyor. So our group project is to create a RDC prediction system using machine learning. I use the decision tree method for this to create the program. So first I have imported the libraries and then I have loaded the dataset. This is the dataset we have used. It's available in Kaggle. So here we have like 920 columns. So next, then I have loaded the dataset as a CSV file. Then I have preprocessed. I just drop the rows with missing values here, since we need all the data for this to happen. Uh, and then I have encoded the category variables like this and feature targets. Then I have analyzed the target like this. It means 0 means no disease and 1 means have disease. Then I have calculated say for random state of 42. Uh, this is the feature scale and have model training such as then I have saved the best model. Then I have evaluated and the accuracy and so then I have generated a confusion matrix for this. Then I have also this is the sample input test data to see whether it's working or not. So this is what I got. So see what it means. It's there's no disease. So for this kind of data, there's no disease. So this is another one. Yeah, this is another test. It gives me one, which means it have the person has heart diseases, small heart disease. Like these are the variables I use. So high blood pressure and high cholesterol, high fasting sugar, high price. Then I have dubbed to save the model as a PKL file. Also, I have saved the scale file. Uh, is saved here. Then I have imported the input for hard disease predictor, which is a front end for this. Yeah, I have created the control.js file. And here you can see uh, in this control.js file. So, so this is the UI file I use for backend. Here I have loaded the model and define the expected columns. Then I have a post request to predict the value. Here's the function I have used. So let me run this. Sorry. In here, this is the policy prediction system. So in here you can write the range system. Then you can see the results. So if you click on predict, it will predict like this. So this person have disease detected. So that's my part using uh, decision tree to predict the data, predict the disease.
I'm Vijay Sir. I worked on implementing a logistic regression model for our heart disease prediction project. The objective is to predict whether a person has heart disease or not based on their medical attributes such as age, blood pressure, cholesterol level, and other indicators. This is a binary classification problem. The target variable is either 0, means no disease, or 1, as disease. If we are talking about the dataset, we use the heart disease UCI dataset from Kaggle. This is the dataset. This step is data exploration. It gives all the columns and rows. This step is data cleaning. Here, handling the missing values in the dataset. Reasoning impute missing values in the CA file and flop columns using the mod, as these are category features, and then import other missing values using the mean or median. Missing values per column after imputation. Data preparation step is task is prepare the data for model training by converting categorical feature numerical representation and scaling numerical features. Here it gives 5 rows and 24 columns. Data splitting another step. Here split the data into training and testing sets. Afterwards, I have gone to model training. Here, train logistic regression model on the prepared data, giving logistic regression. If we are talking about model evaluation, here we are doing a subtask evaluate in the trained logistic regression model using accuracy, precision, recall, and F1 score. They are given accuracy 0.625, precision 0.545525, recall 0.37, F1 score 0.35. I added some details regarding my algorithm also. If you are I have already tested on two custom inputs. If you are adding this input, it's giving the person is likely to have heart disease or target one. Again, I have added another custom input. Again, I will now add one custom input also. We are running this thing. We are running this. It should give that patient does have heart disease symptoms. Yes, it is giving. This is my overall logistic version for the project assignment. Thank you.